Today I want to talk about chemical reactions. Again, this is a chemistry concept. Um, so a lot of us probably have not had much chemistry when we take this GD test. So we're going to try to keep this as simple as possible. So one of the things we want to talk about to start with is this law of conservation of matter. So this is one of the big things in physical science. What it says is this: matter can neither be created or destroyed in chemical reactions. So in a chemical reaction, we have what we call these reactants. So if you look over here, this side of the equation is the reactants. The products are the other side of the equation. What has to happen is whatever we have on the left side has to balance out with what we have on the right side. So notice how there are two key elements involved here. H stands for hydrogen and O stands for oxygen. If I look at this chemical equation, the H2 stands for a hydrogen molecule. The coefficient means we have two of them. So notice how there's this hydrogen molecule here and this hydrogen molecule here. But notice how many atoms of hydrogen we actually have. We actually have 1, 2, 3, 4 hydrogens over here. And what we're adding to that is this O2, which means we have one oxygen molecule, or we have two atoms of oxygen. So when it comes to this other side, the products, what we're making is H2O, or in other words, we're making water. So this H2O actually represents a water molecule. So notice how we have two water molecules. That's where this coefficient of 2 comes into play. But if we look at the actual atoms, notice how there's this coefficient 2 goes with this subscript. This 2 times 2 means there's actually going to be 4 hydrogens altogether, 4 H's, if you will. So notice how I have 1, 2, 3, 4 H's. So we had 4 H's over here, and we also had 4 H's over here, so that balances out. This coefficient 2 also goes with the O. That also means there are 2 oxygen. So if you look over here, there are 2 oxygen as well. So this meets the law of conservation. We have the same number of atoms in the reactants as we do with the products, and therefore the equation is considered balanced. Now it's going to be our turn to see if we can actually balance a chemical equation. Now we're not going to actually draw it out this time. We're going to just try to follow it by just using these symbols. So Na is an element, Cl is an element. F2 means we have 2 Fs. Over here we have 1 Na, 1 F, and 2 Cls. So we have to balance this out. So the first thing that, if I'm looking over here, I have 1 Na and I've got 1 Na, but in the Cl department over here, I actually have 2. Again, to balance this out, what I'm allowed to do is put a coefficient in. So this now says I have 2 sodiums, or 2 Nas and 2 Cls. And over here, I have also 2 Cls. So the Cls are now balanced. The catch is, though, when I put that 2 in front of that Na, I got to now put a 2 in front of that Na, because now that balances out the Nas. I have 2 Nas here, and I now have 2 Nas over here. The catch is, what about the F2? Well, if I have 2 F2s here, if I have 2 Fs here, I got to have 2 Fs over here. And remember, the coefficient means it goes with the F as well and says that there are 2 Fs as well. So this means we are now balanced. I have 2 Nas, I have 2 Nas. This 2 goes with the Cl, and the subscript means there is a chlorine molecule over here, a Cl. And then this subscript here, this 2 means I have 2 Fs here, and this coefficient goes with this F to make that 2 Fs. So it's now balanced out. So if I look at this next one, I have a carbon and a hydrogen. In other words, I have one C and four H's. I don't know what that actually is as far as the molecule goes, but it has one carbon and four hydrogens. I'm adding to that two oxygens. And this has a reaction. Again, this reaction goes this direction, how the arrow goes. Always follow these arrows. They kind of tell you the direction you're going in. So this is what I'm starting with. And I'm ending up with a C, two oxygens here. Also got two hydrogens and an oxygen. Now the catch is I have to have the same number of each on each side. So if I look over here, the carbon and the carbon matched up. But as far as the hydrogen goes, that four means there's four hydrogens here. The only H I see over here is this H over here, and it says there's only two here. So I must put a two in front of that. Now I have two times this two here, which makes four H's. And that's what I have over here are four H's. So that balances out. As far as the oxygen goes, I have two over here. Now over here, I've got these two here, but remember this coefficient goes with this O over here. That means there's two O's here and two O's here. That means there's four O's over here, which means I've only got two over here. I would have to put a coefficient in front of that O there to now make four, because that subscript goes with that coefficient to make four. So that means there are now four oxygens altogether. So now the equation looks like it's balanced. I have a carbon, I have a carbon, I have four hydrogens, I've got two, but this two here means I've got four altogether. I've got two oxygens present, but this two here means you got four altogether. Over here in your products, I have two here, and this two goes to that O, which makes two, and two, which makes four. That's now balanced out. This bottom equation, I've got like three lithiums and one nitrogen. So three Li's, one N. I've got one N, four H's, one N, and three H's. I've got an Li, an N, and three O's. What's tricky is this guy over here. It's got like in parentheses, this three on the outside. This subscript means there's actually three nitrogen and there's actually 12 hydrogen already present over here. And then there's this other nitrogen over here. So that looks a little complicated to start with, but let's just take it piece by piece and see what I can figure out. Well, the first thing I observe is there's this three here, which means there are three Li's. Over here, there's not a subscript, which means there's only one Li. But the only thing I'm allowed to introduce into the problem are coefficients. So to balance this out, I could put a coefficient of 3 in front of this. So now I've got my lithiums balanced out. There's three Li's, and now there's three Li's. The next thing I look into is, well, these nitrogens are all over the place. So I'm going to leave the nitrogens alone. The hydrogen looks like it's in just one spot here. There's four hydrogens here. If you look over here, though, there's actually 12 hydrogens over here. So 3 times 4 gave me this 12 hydrogens. So to make this work, I got to put a 3 in front of this expression, which now means this 3 also goes with the N's, the H's, the N, and the O's. So what I have then is 3 times 4 makes 12 hydrogens. I've now balanced that out. Let's now look at the O's are only in one spot, so hopefully the O's play out too. So notice that this 3 and the subscript on the O's makes 9 O's. And I got the same over here, 3 and 3 makes 9. So that looks like the O's are good. I've got 9 O's on each side, so that looks like that balances it out. So I've got this N here, there's 3 here, and there is 3 here as well. So it looks like there's 7 nitrogens present here. If I look over here, you have 3 N's, And this subscript goes with this end, so there's 3 ends there, and there's another end out here that looks like the ends are all balanced out as well. So we're good to go. That equation is now balanced. So you have one of these compound molecules. We have 3 of these compound molecules. We have 3 of these compound molecules, and we just have one of these molecules here. If I erase the box there, so that this is a molecule of whatever that represents. Okay. So we are balanced though, and that's kind of what you may have to do on the GD test is balance a chemical equation, and it's all about these coefficients in the right spot. So hopefully you find that helpful.